So with a rather simple setup, I can control almost anything electrical I want with an Arduino. Now, as we all know, the Arduino has limited power output. We're talking about a few volts at a few milliamps. So how can you do that? Okay, so, well, let me show you. It's a rather simple setup. We'll go over the hardware and the software, and I'll show you how I make this happen.
Let's do a demo. This is kind of a silly demo. It just turns the light on for 1 second out of every 3. Now, I'll show you the code to do other things. I've got a lot of different examples in my code. But, if I have one turn on next week, on next Wednesday morning at 1 o'clock in the morning, we don't want to be sitting around waiting for that. So, this is something quick and dirty so I can demonstrate the code works and the circuitry works. Here we have the power supply. You can see it's running at 8.2 volts. Why am I running it so low? Because otherwise this thing blinds the camera. It's so bright. I can show you here. Let's crank it up just for fun. Yeah, you can see what starts happening as it freaks the camera out. So we'll turn it back down to 8. Okay, so this is the power supply. This is what the solid state relay is controlling. So this solid state relay is turning on or off the big power to this LED. I've got something else we can hook up to it briefly, but it'll drive you crazy, so I won't do it very long. It's a big pump. And the Arduino, of course, is controlling the solid state relay, and it is based on the time that is coming from the real-time module back here. So that is the whole setup. It's rather easy. Of course, we have that circuit diagram. And yeah, otherwise this is it. This thing can control 40 amps, and it requires very little power from the Arduino. The Arduino can power many of these things, so I think I can't remember how many pins are on the Arduino, but anyway, this just requires one digital pin and one ground, and that's pretty much it. You can have a series of these controlling a lot of big things. Okay, so let's hook up the pump and see what happens. This is the demo of a really high output device. It requires up to 15 amps at 12 volts. As you can see, the Arduino has no problem switching it on and off. Yeah, it's going on 1 second and then going on for 3 seconds. That's not a great application, but it's a good demo. Yeah, but I could turn this on, say New Year's next year, and at 1 o'clock in the morning, whatever I need to do, I can get the time from the real-time clock. The Arduino says, okay, now's the time, turn it on for X amount of time, turn it off, and then of course that can be in conjunction with a lot of other things. You could have water sensors, light sensors, anything you need. So anyway, yeah, so this is our setup.
This is the rather simple setup. There's only 3 components, as you can see. There's the real-time clock, the Arduino, and then the star of the show, which is the solid state relay, this thing over here. The real-time clock, I've got several videos on how to use that. It can be a little bit complex, but I have a lot of detail in the other videos, so I'll just go over it briefly here. We have the VCC connected to 5 volts on the Arduino. Ground is here. The data line goes to A4, and the clock line goes to A5. Okay, again, the Arduino. And over here we have the solid state relay, which to me is really an amazing device. It literally has no mechanical parts. It doesn't go click clack like a mechanical relay. The really wonderful thing about it is it can control a massive amount of output power on this side, but on the input it only takes a few milliamps and a few volts DC to switch it on and off. So yeah, it's not like the heavy coils in a relay, which require quite a bit of power to activate. This thing can be activated by very small amounts of current, which means you can have multiples of these on one Arduino. So whatever you're controlling, yeah, you can control a lot of different things with one Arduino. Okay, so this side we've already talked about. On the other side, we can control 5 to 60 volts DC at 40 amps. I've got another clip where I'll show you both an AC and a DC version of this solid state relay. But on our video today, I'm using the DC one. We just have a power supply here. It could be a battery. The load I'm using is either an LED or a pump, and then back here to the minus. So again, the setup is very simple, very easy to use. Okay, so that's it for our system diagram.
These are the solid state relays. We have AC, DC depending on your preference. We have, this one runs from 24 to 380 volts AC on the output. This is the output stage. And this one is 5 to 60 volts on DC. Note that they both are triggered by 3 to 32 volts DC on the input. So even the AC is triggered by DC inputs. And it's very low current on the input, so you can control many of these with the Arduino or any of the small processors.
This is the code that makes all of this happen. And you'll find that most of this code is actually to get information back from the real-time clock. Yeah, it's in fact the code that does stuff controls the pump or light or whatever is just these little sections down here. Okay, but I'm getting ahead of myself. So this is the for the Arduino. It's written in C. Basically, it's the date time control of anything using the real-time module, the DS3231. It, as we saw in the diagram, these are, I won't repeat all this, the solid state relay, the positive is connected to pin 4, the input minus is connected to ground. We include the wire library, and this is again for the DS3231, and then we're using the default address for the real-time clock as well. These variables are to get the hour, minute, second, day of week, date, month, year from the real-time clock, and this is an array for getting the year, month, and day, and then this is an unsigned long, year, month, day, character, hour, minute, second, again an array, unsigned long, hour, minute, second. So I'm getting this as BCD and I'm converting it. Again, this is a very complex thing which I won't go over this time around. Other video, check my other video on it. And this is a pointer to year, month, day, and this is a pointer to hour, minute, seconds. Moving down, this is a very important, very short but very important routine to convert BCD to decimal, which the real-time clock works in BCD, which is kind of a strange thing. And so when we grab information, grab date and time from the real-time clock, we need to make sure we convert it to decimal so we can use it in our logic. Then down here, this is where we get the information from the real-time clock. So this is the routine that does it, and you can see I've got these variables that I defined up earlier: the byte, second, minute, hour, day of week, date, month, and year. This is how we trigger the real-time clock, sorry, the I2C bus. So we open the I2C bus to reach the real-time clock. This is where we do a write, so that sets the register to 00 hex. And then this is the end of transmit, and it tells the real-time clock to send data to our program. Now, the request, this is to get 7 bytes from the real-time clock buffer. So that's what this is. This is the address, and then this is a request for 7 bytes. Here we have seconds, so we're going to get the seconds. We're going to remove the high order bit because that's undefined. We get the minutes. The hours are in the next byte. Then we're going to take off the top 2 bits here. Day of weeks is the next byte. Date is the next byte, month is the next byte, and year is the next byte. You can see all that over here in the comments. Okay, a very necessary routine is to convert that BCD time into something we can use. So we've gotten the real time data, and these are pointers to those data variables. I am printing this out. You can see it running over here. It's absolutely not necessary. I'm just doing it to show that the BCD, the time that we get, and the integer time is the same. And so this is the year, month, day, and then hour, minute, second, hour, minute, second. Okay, so that just shows that what these routines are doing, it's converting from BCD to integer, because we can't really do valid mathematical comparisons with BCD easily. Okay, so anyway, onward. So this is the get real time, and that's this routine here, we call that. Then we do an sprintf, so as you know, that formats this data using this format statement into this variable. And then the year, month, day of that is a string to integer, so we convert this into an integer. Then we print it, and that's again happening over here. Similar with the sprintf, the hour, minutes, seconds, using the format, so hour, minute, second. Use this format, stuff it in that variable, and then again we convert that into an integer, and then we print it. So that's what you're looking at over here. This, of course, is the required setup routine, and all we do is we have the I2C, we have to join the I2C bus, and we're going to do that as primary, which is the default. We are going to open the serial port, the COM3 port, which is this over here. And then we are going to define pin 4 as an output. And again, we're using that over here with our solid state relay to turn on our solid state relay. Following that, I've got, you say, wait a minute, these are all comments. Yes, so these are different routines that do different things. This is the exact example I was running. This is the demo. So this is actually what we were looking at a little bit earlier. And let's just start up here and look at some of the different things you can do with this setup. This one it'll turn on every day at 2200 hours and off at 2200 hours. So it will turn on and off the solid state relay on these times. Now you cannot do this with a normal timer of the Arduino, because the normal timer of the Arduino is based on when you turn on the device. And yes, you can count the milliseconds and all that, but you know, it's not a real-time clock. It doesn't give you wall clock time. Okay, so that's what this is doing right here. And again, it's just turning this on if it's in this time frame, and then it turns it off if it's outside of those times. The next routine will turn on the pump or light, whatever, for the even hours of the day. So 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock. So if you wanted to do something along those lines. So this is quite simple. You just take the hour, and if the result of ampering that with 1 is 0, then we know it's an even. And then we turn it on, otherwise we turn it off. Okay, this routine is the one we're actually running, and if seconds amper 3, so we turn the pump or light on for 1 second every 3 seconds, and you see that here the delay is 1 second. Otherwise it's off. So yes, if it's divisible by 3 evenly, then it's on, and otherwise it's off. And then the last one is something kind of silly I did. This turns on the 4th of July on 2099, in the year 2099. So yeah, at midnight on July 4th it will turn on, and then otherwise it will turn off. Okay, so as you can see, these routines, you can modify these routines to pretty much do whatever you want. Anything that's based on wall clock, anything you need to do on wall clock, lights, motors, pumps, anything like that, you can control with one of these solid state relays on an Arduino and a real-time clock. Okay, well that's it for controlling just about anything with an Arduino. Hope you found it useful and interesting in your Arduino programming and applications.